So hi students, welcome to the sprint session of your electromagnetic induction. Sometime back we were not able to continue with our physics sprint sessions. Really sorry for that, but from here onwards till the end of your semiconductors we are going to have the regular sprint sessions. All right, so let's get started off without any further delay. Let me just introduce myself to all you students who are watching me for the first time on this particular platform. My name is Sumit. I am a BTech graduate from IIT Bombay and I had a rank of 2125. That was way back in the year 2003. It's been now 10 years of teaching experience, trying to motivate, guide and handheld students to reach to their dreams of the prestigious colleges in this particular country. Hope we'll be able to do the same for you students. I hope we will be able to do that for you students. Chalo, let's go ahead and let's discuss some very important things from your point of view. Currently, India is in lockdown and we have got 2 more months for your JEE mains, right? Now, under these current circumstances, that there might be a situation where you would want to actually study some extra topics, maybe revise some topics in greater detail, all right? So for that particular thing, we have this particular URL, that is tinyurl.com/JEEmobile. This website, if you go to, you will get free video lectures of 11th standard and 12th standard for physics, chemistry, maths for both the standards. So it's like a video book and just go ahead and enjoy it as much as possible because it is all free of cost. All right. Acha, by the way, if I am talking about the plus subscription now, okay, now that was free. Now this is something which is like more valuable, all right? But this also comes at a very less price. Okay, what is it? It is the Netflix of education, okay? You have access to the top educators of this particular country, and besides that, also you have lot of courses, lot of different kinds of packaging of courses which are taking place in the Plus platform. So you are open to all of that at a very minimal price. Okay, generally for 1 year it comes to 30,000, right? And for 2 years it comes to 36,000. But under the current circumstances, the prices are anyways at all-time low. And if you use this code, which is very easy to remember, Superman Live, okay, SM, Superman Live, you will get the maximum possible discount. So for 1 year, the prices would be coming to what, 27,000 only, and for 2 years it will come to 32,400. So if you look at the prices per month, it actually reduces down to something around 1350 per month. 1350. I think that is a peanut for something which is so valuable. All right, chalo bachcho, so we'll discuss more about the features of the Plus subscription towards the end of our today's lecture. But let's get started off with our first question. Now, what does our first question say? It says that there is a coil which is a resistance of 100 ohms and there is a current which is induced by changing the magnetic flux through it. Okay, so we know magnetic flux is going to change. If magnetic flux is actually changing, okay, what is going to happen? EMF is going to be induced. And if EMF gets induced, we know current is going to flow in that particular coil. So we need to find out the change in magnetic flux. Okay. Now they have given to us a graph between current and time, where current is decreasing with time. All right. So how do we go ahead and solve it? See, try and understand. We are going to make use of 2 laws out here, which you know very well. That is your Faraday's law and the Ohm's law. Now, what does the Faraday's law tell me? The Faraday's law tells me that the EMF induced is equal to d phi by dt. Simple idea. It is equal to what? D phi by dt. And the Ohm's law tells me that the EMF induced is equal to IR. Okay, now let's say this is my equation number 1 and this is my equation number 2. So if I combine both these equations, what would I get? I would get d phi, all right, I would get d phi by dt as equal to I times R. Simple idea. Okay, now we can play around with this equation. We will get your value of d phi as equal to IR into dt. Okay, now they have asked us to find out the net flux that got changed, that was associated with the coil. So in order to find out the net flux, what we will do is we'll go ahead and integrate the entire thing. So once we integrate, what do we get? We'll get the total change in flux. Let me call it as my delta phi. So delta phi will be equal to R. R is a constant, so it can come out of the integration sign. Integration of I dt. All right. Now let us try to understand what is this integration of I dt. See, integration of I dt is nothing but the total charge which is flown through the coil. Okay. Now there is a mathematical significance also of integration I dt. See, it is nothing but area under the curve. Which curve? Curve of current versus time. So we have a similar graph out here. You can see this graph here. It is current versus time, and this entire integration here is nothing but it's the area under this curve. So what is the area out here? The area out here is equal to the area of a right angle triangle, that is equal to half. What is the base? Base is also 0.5, that is again half. Okay, that is 0.5 into the height, that is 10 ampere, that is equal to 10 ampere. So overall you will get this as 2.5 coulomb. Right, because I said that integral of I dt is nothing but it is have the dimensions of charge, and charge is that of coulomb. So you got the value of what? The area. That means you got the value of this particular portion out here, this particular portion out here. Okay, so once you have this, you can easily calculate what is the value of the change in the flux. So the change in the flux will be equal to what? The change in the flux will be equal to delta phi will be equal to, let me just put down the values right now. It will be 100 into 2.5. So if you multiply this, you are going to get 250 Weber. That is your answer, option B. Fine enough. So you can go back to the previous options page and look out for yourself that it is option B which has got 250 Weber. Alright, now students, if you have enjoyed this particular problem, you know what you have to do. Go ahead, press on the like button. So let's move ahead to our next question. Now, what do we have in our next question? Let us try to see it. Chalo, let's change the page. So we go ahead and we have our next question. Something very interesting. This question came in for JEE Mains 2009 paper. Okay, see, what does this question tell me? Let me just explain that to you in the first. Okay, now there is a magnetic field in this region. Try and understand, there is magnetic field in this region and it is pointing into the plane of the screen, whatever you are watching. Okay, so it is pointing into the plane of the screen. And the second thing which has been mentioned, that it is actually increasing with time. That means dB by dt is greater than 0. So net magnetic field is increasing into the plane of your screen. Alright, now they are saying that we have got two loops, loop CD and loop AB, okay, and I1 is flowing in AB, that is the inner loop, and I2 is flowing in the outer loop, CD. So we need to find out among these options, I1 will be greater or less, it is going in which particular direction, from A to B, I1 is going from A to B or from B to A, I2 is going from C to D or D to A, alright. So this is what we need to find out. So let's go ahead and try to look at the solution. Okay, now let's say we have got just one loop. We will draw the other loop later down the line, but let's say for understanding purpose, let's say we have got one loop. Okay, now we said that the magnetic field is into the plane of the screen and it is increasing with time. So the current induced in the outer loop, alright, will be equal to what? It will try to do what? It will try to decrease. It will try to decrease the magnetic field going into the plane of your screen. So the current induced will be such that it will generate magnetic field in the outward direction, right? If it generates magnetic field in the outward direction, how will the current flow? Let's try to see this. How will the current flow? The current is going to flow like this. All right. So it is going to flow. That is I2. I2 is going to flow from D to C. All right. I2 is going to flow from where? D to C. Now, inside you have got another loop, all right, which is the smaller loop. Let's say this is the smaller loop that we have out here. So let me just finish this smaller loop out here, and this is my loop AB. Okay, so if you look at this portion inside this loop, see what is going to happen eventually. See, inside the bigger loop, because it is opposing the magnetic field going into the plane of the screen, all right, it is going to induce current such that the magnetic field is in the outward direction. So all of these magnetic fields will now be pointing in the outward direction. These magnetic fields will be pointing in the outward direction, as you can see here, all of these particular points, right? Now, so there are regions inside where magnetic field has been induced in the outward direction. So what it will do? It will try to oppose it. The current I1 will try to oppose the magnetic field coming out, isn't it? So what is it going to do? It is going to induce current in such a direction that the magnetic field will be pointed into the plane of the screen. So the current I1 is going to flow in this particular direction. I hope this concept is very, very clear to each and everyone. It's a very, very useful concept, and who knows, maybe you can expect this in this year's second phase of your JEE mains or even advanced. So if you've liked it, like and share. Send it to, send it to as many students as possible, yaar. Send it to as many students as possible. This is the crisis time, and exposure to good problems is the right of every Indian. Okay, chalo, let's move ahead to the next question. What do we have in the next question? Let's see. Let's move ahead. So, I think the next problem is, wow, this is a very interesting problem, that is of JEE 2004, and let me tell you, I can solve this problem for you in just 30 seconds. Okay, but if I'm trying to explain this to you, it is going to take a little more time, but you can solve this question in like 30 seconds. How exactly? See, what does the question say? Let us first try to understand this. Okay, so here I have got a coil which is like in a solenoid. Okay, it's like in a solenoid, there is a coil, and there is a bar magnet which is coming right in this particular direction towards the coil. Now see, when it is very far away, this bar magnet, when it is very far away, okay, there will be lesser magnetic flux associated with the coil. There will be lesser magnetic flux because it is far away, isn't it? But when it comes closer to it, the number of magnetic flux associated with the coil is going to increase. So there is change of flux, magnetic flux associated with the coil, as a result of which EMF is going to be generated. Right. Now this EMF that gets generated is being plotted versus time. So we need to tell actually which is the correct graph out here. So in order to understand that, let me take a situation out here. There were multiple loops, but we will take only one loop. Okay, the situation is going to be the same, right? So here I've got a magnet which is on the left side of this particular loop and it is approaching. So let me see that this is the north pole. Let's assume that this is the south pole. It could be south or north, doesn't make a difference. Okay. So when this north pole is approaching this particular loop, what is going to happen as per Lenz's law? See, this side is going to develop a north pole out here because it is going to oppose the cause which actually creates it, isn't it? So it is going to develop a north pole so that it can repel the magnet from coming towards it. It can repel the magnet from coming towards it, isn't it? So this side will be north pole current. If you look at it from this side, it is going to be what? It is going to be in the anti-clockwise direction, and from this side, if you look at it, it is going to be from the clockwise direction. So this side will be north pole, this side will be south pole. Very good, you have understood. So EMF will be generated in one particular direction. Is this clear? Now let us move ahead and let us try to look at the other scenario. Okay, so what is the other scenario that we have here? Let me just go to the next page. Okay, excuse me. Okay, so in the other page that we see here, we know that this is going to be the south pole and this is going to be the north pole. See, the magnet has crossed the loop and it is going in the other direction. Now, what is going to happen? The magnetic flux associated with the coil is going to decrease. So if the magnetic flux is decreasing also, it is changing. So it is going to develop a EMF. All right. Now here, since it is going away, it will try to oppose it. So if it is trying to oppose it, there will be north pole set up out here, there will be south pole set up out here. So if this is happening, then what is going to happen? What did you observe? Now the current is going to flow all together in a different direction. That means the direction of the EMF has actually changed. Did you understand this? Now let me go back to the options. And analyze those graphs that we had seen in the beginning. So let's move ahead to the graph side. Okay, just give me a second. Okay, so you can look at these graphs out here. If you look at option A, the EMF is constant. It does not change. All right, it's not constant, the direction is constant. That is that it is never going in the negative side of the EMF. So it is always above the t-axis, right, above the x-axis. So it is always positive. So is option C, so is option D. But we know that the EMF is changing its direction as the magnet is going from the left hand side to the right hand side. So we have option B as the correct answer. I hope everybody got it, enjoyed this particular problem. You know what you have to do? Press on the like button. Go ahead. Chalo, let's look at the next interesting problem that is coming up for you students. Wow, this is a JEE advanced problem and it looks very, very interesting. Chalo, there is a lot of text on the screen. You don't have to read through all of that. Let me go ahead and explain this to you. Which are the correct options? Is or are? There are multiple, by the way. This is a multiple choice question. So what we'll do is, let us first try to understand what does the diagram tell me. Okay, so see, there is a loop which is in the shape of a 8. So it's just one wire. It's not two independent wires. It is just one wire which is creating a 8 out here. So the area of the smaller loop is A and the area of the bigger loop is actually 2A. And the magnetic field is into the plane. Right. Now, what is happening is this entire setup, this double loop, all right, is kind of rotating with an angular velocity of omega. So it is going to generate some EMF in this double loop. We need to find out what will be that EMF. Okay, now let's look at one option at a time. So we'll take up the first option, that is the EMF induced is proportional to the sum of the areas of the loop. Okay, so let us try to understand what is exactly happening here. So let's say the current in the upper loop is flowing in an anti-clockwise manner. All right, so see, here it is going to come here and the current in the bigger one, see, the current goes here and like the trajectory of the current flow is like this. All right, so here if it is flowing this way, here it will flow in the opposite direction in the clockwise manner. So what will be the direction? See, we are trying to find out the EMF. In order to find out the EMF, we should know the flux, right? And in order to find out the flux, we should have the sense of the direction of the area, right? So here we are trying to find out the direction of the area. So see, if the current is flowing like this, it is this way. If it is flowing like this, it is this way. That means what? The area in two different loops, the upper loop and the down loop, are in two different directions, which means the net flux that will be associated with this particular double loop will be equal to B into 2A minus A into cos of theta. All right, it will be equal to B into 2A minus A into cos of theta. Now, what does the option tell me? The EMF induced is proportional to the sum of the areas. Well, no, it is not proportional to the sum of the areas. Rather, it is proportional to the difference of the areas. So, option A cannot be the right answer. All right, everybody got it? Chalo, let's go ahead to the next option. Let's go ahead to the next option. This is very, very clear to everyone, I guess. Okay, fine. So you are doing all JEE advanced level problems. My goodness. So definitely the JEE mains level problems are going to look very, very easy for all you students. Okay. So what do we have in this particular question? See, it's the same question. It is the second option, option B. Let us try to analyze it. The rate of change of flux is maximum when the plane of the loop is perpendicular to the magnetic field. Plane of the loop, when the plane of the loop, that means the direction of the area is perpendicular. Okay, so how do we find it out? See, the rate of change of flux. The rate of change of flux is what? The flux, we defined it as equal to BA cos of omega t. Because see, if it is rotating, all right, the theta angle that it is going to rotate is going to be equal to the angular displacement, and angular displacement we know will be equal to what? Omega t. Omega is kind of constant. So here the EMF, the rate of change of flux, that is the EMF, all right, will be equal to d phi by dt. All right. So when you calculate that, you will get B into A omega sine of omega t. Right, sine of omega t. So EMF, or the rate of change of flux, all right, is going to be maximum when this quantity is going to be equal to plus 1. And when does it become equal to plus 1? Simple idea. When the angle is equal to 90 degree. Then what is this angle? It is the angle between the loop and the magnetic field. So yes, the rate of change of flux is going to be maximum. This is the correct answer. All right, let's go ahead to the next option. Okay. So what do we have in the next option? Let's just see it quickly. What do we have in the next option? Okay, the net EMF induced is proportional to cos omega t. We have just seen that the net EMF induced was proportional to sine omega t. So this option is not the correct one. So we have got option A and option C to be wrong. Option B so far is correct. So let's go ahead and see the last option. What do we have in the last option? Amplitude of the max EMF due to double loop. Amplitude of the max EMF, we know the EMF induced due to the double loop has come out to be BA omega into sine of omega t. So the maximum value of the EMF is actually this part, BA omega, isn't it? Now, what is the maximum value of the EMF due to smaller loop? That is this particular loop, the smaller loop out here. Okay, so we know that EMF induced here will also be equal to BA omega sine of omega t, right? Why? Because see, the area is A, so flux will be BA cos omega t, right? So if you differentiate it with respect to time, you will get BA omega sine omega t. So the maximum value is going to be the same. Option D is the correct answer. All right, so you can easily solve even advanced level problems once you have a good understanding and confidence within yourself, and you definitely do have it. After this session, I can definitely assure those 4 marks that you're going to get for your JEE mains, and maybe who knows for the advanced paper also. If you're able to keep your cool and maintain your calm, you can crack any problem. Okay, chalo, let's go ahead and see this particular problem. This is also from a JEE advanced previous year's problem. What does it say? See, here I have got an infinite wire, and there is a current moving into this. Okay, now this particular current is increasing with time at 10 ampere per second. It is increasing with time at 10 ampere per second. And below I have got a right angle isosceles triangle. I need to find out the EMF induced in this particular loop. Okay, chalo, let's move ahead. Let's see what will be the value. So what are the options? Mu naught upon 2 pi, 2 mu naught upon pi, mu naught upon pi, mu naught upon 3 pi. Okay, so we have looked at all the options. Now this is the infinite wire that we were talking about. This is the isosceles right angle triangle. Now in order to find out the EMF, okay, we need to know the function for flux. Because once we know the flux, we can differentiate it with respect to time. We can differentiate it with respect to time to find out the EMF. Simple idea. Okay, so let's go here and let's try to find it out. Okay, now for finding out the flux, see, try and understand what will be the magnetic field due to this particular infinite wire. The magnetic field, let's try to see, will be equal to, see, one simple understanding. Why are we taking the element? First of all, why aren't we multiplying it directly with this particular area of the loop? We cannot do that. Why? Because if you see, the magnetic field is equal to mu naught I upon 2 pi y. Why? What is y out here? See the distance of the points from this wire. See this point, this point, this point, all these points are going to have different values of magnetic field. Why will they have different values of magnetic field? Because of the fact that the magnetic field is inversely proportional to y. So here I cannot multiply the magnetic field that is being generated due to this wire with the area out here. Alright, so what we'll do is we'll take a small element in order to find out the flux, that is d phi, and that will be equal to the value of the magnetic field into the area dA of this particular element. Now, how do we find out the area of this particular element? This point is very, very clear. Alright, what is it? That we cannot multiply directly the magnetic field into the area of the entire loop. So we need a small loop out there, isn't it? So this particular loop that we are talking about here, what will be its area? So let's try to understand this. We'll rub it off. Okay, we'll rub it off and then let's try to understand this. Okay, see, if you look at it, this is a isosceles right angle triangle, so this will be equal to 45 degree. This is 45 degree corresponding angle. This will also be equal to 45 degree. All right, this is a bisector of 90 degrees, so this will be equal to 45 degree. If this is 45 degree and we are taking this element at a distance of y from this wire, then what will be this distance from here to here? This will also be equal to y, isn't it? Now, if this is equal to y, these are like congruent triangles out here. So this part will also be equal to y. So what will be the total length of this element? It will be equal to 2y. Simple idea. So what will be the area? Area will be equal to b into 2y. And what is the thickness of this element? It is equal to dy. So length into breadth, that is what we are applying out here. So it will be 2y into dy, that will be the total area. Is this clear? So what will be the flux that will be passing through this particular element? See, we'll multiply b with this particular thing. So here we'll get mu naught I divided by 2 pi y into 2y into dy. Wow, this is superb. Let me just cancel the important terms. 2y gone, and we get d phi as equal to, mu naught I into dy divided by pi. Now we need to find out the total flux which is passing through this particular right angle isosceles triangle, because once we find out the total flux, we differentiate it with respect to time and we'll get the value of the EMF. All right. So once I find out the total flux, I just integrate it and I get the total flux as equal to mu naught, okay, mu naught I into L divided by pi. Okay, mu naught I L divided by pi. L is what? L is this entire length from here to here, because you are integrating this particular dy. So you are reaching from here to this point. When you reach from here to this point, you cover up the entire area of this isosceles right angle triangle. Okay, so I think this is pretty clear. Now, what do we do here? Simple idea. Let me just take the EMF then as equal to d phi by dt. Okay, so once you calculate your d phi by dt, what will you get? Simple idea. Excuse me. You will get mu naught L upon pi into di by dt. Simple thing. Now you go ahead and put down the values, mu naught L. So mu naught upon pi, you get it here. L is equal to what? L is equals to this is 10 centimeter. All right. So 10 divided by 100. Okay. You convert it into meters. Simple idea. Di by dt. What is di by dt? Di by dt was the rate of change of the current in that upper wire. So that is 10 ampere per second. If you see this, it will cancel out completely. So the answer is mu naught upon pi. That was your option B. All right. I hope everyone's understood it. You've just solved the JEE advanced level problem. Okay. So let's move ahead to the next question. I think definitely your confidence is actually going up. Okay. When you look at these kind of problems and you are able to solve them, definitely your confidence is going to be boosted up. All right. Chalo kids, let's move ahead to our next question. And what is that? Let me just check it out. Okay. So let's moving ahead to the next question. God bless you, all of you. So we found out the EMF induced. Anyways, and now we'll try to find out what is the direction of the flow of current in this particular loop. Okay, see, direction is usually a pain area for a lot of students, I understand, but let us try to understand it or analyze it very, very closely out here. See, this wire is carrying current in this particular direction. So where is it going to induce the magnetic field? In the below region. If you use this rule here, it is going to be into the plane, right? So the magnetic field is going to be into the plane of the screen, and since di by dt is increasing with time, the magnetic field is also going to increase in the direction of your screen. All right. So the current flowing in the loop is going to be in which direction? It is going to be opposing it. So if it is going to be opposing it, the current is going to flow in the opposite direction. The current is going to flow in the opposite direction. See, try and understand. Okay. We are not creating a mirror image out here. So it's like, whenever I'm doing this, it's like going into the plane of the screen, but it is otherwise, because I'm standing on the other side of the screen, right? So that's the reason why. So you should be able to understand it. Okay. So if it is like this, it is in this direction, it is going to oppose it. All right. So the current is going to flow in this particular direction. I hope the idea is very clear. So the current is going to flow in a anti-clockwise direction. All right. Chalo, let's move ahead and let's explore our next question. Okay, so what do we have in our next question? Let's just go ahead and see it. Well, this is another bombastic question out here. No, it's not. It's a very simple one. The diagram looks very, very complicated though. All right, but you should not be afraid or scared of the diagram. Let me explain to you what is the question like. See, there is a loop out here. All right, there's a loop out here and there's a magnetic field which is coming out of the plane of the screen. Okay, and this entire setup is moving towards the right with a velocity of 1 centimeter per second, and there is an arrangement of resistors out here. Okay, see, the magnetic field is equal to 1 Tesla. These are the data which is given to me. We need to find out what is the current flowing in this particular loop. So there will be EMF generated. EMF will be generated because what? Because of this loop is moving towards the right. Okay, so EMF is going to be generated. By the way, there is going to be resistance. There is a resistance of this loop also, which is 1.7 ohms, and this will also contribute to the resistance of the entire loop. So given this particular thing, you will get the net value of the current, that is the EMF, by the resistance of the entire setup, that is of this portion and this portion. So let's go ahead and see how do we calculate it. So the first thing that we are going to calculate is the EMF induced. So let's try to see it. Okay, so let's try to see it out here. Acha. So see that magnetic field, it is all in the magnetic field, and the magnetic field, so the loop is coming out of the magnetic field. So what is happening? The flux is decreasing. If the flux is decreasing, that means it is changing. So EMF is going to be generated. Now the EMF that gets generated, it is given as your BL into V perpendicular. Now what is this V perpendicular? Let's try to understand it. Okay, so whatever is the length of the rod, we take the component of the velocity which is perpendicular to the rod. Okay, we take the component of the velocity which is what? Perpendicular to the rod. So let's try to see out here. See this two ends that we have here, will there be any potential difference or EMF generated across the ends of these two rods? No, because the velocity is in this direction and the rod is also in the same direction. Okay, now if you look at here, what is going to happen? This, see, by the way, this and this, both cases there will be no EMF generated across the ends of these two rods. Okay, but if you look at this rod, the velocity is in this direction and the rod is in this particular direction. So yes, this is the perpendicular component of the velocity, that is the velocity which is perpendicular to the rod out here. Okay, so what is going to be the EMF out here? That is very simple. Let me just calculate it. Magnetic field is equal to 1 Tesla. Acha, length is equal to 5 divided by 10 to the power 2. Okay, acha, what is the velocity? V perpendicular is equals to 1 centimeter per second, so that is 10 to the power 2. 1 divided by 10 to the power 2. What are you going to get? 5 into 10 to the power minus 4 volt. Okay, pretty clear. Acha. Second thing is, we'll try to find out the net resistance, R net. Okay, so what is going to be the R net? See, this one has got a resistance. Fine, we'll talk about it. It is given to me in the question itself. If you look at this part here, see, 2 by 1, 2 by 1, it's a balanced Wheatstone bridge. Arey if it's a balanced Wheatstone bridge, I don't have any problem in life, because this 3 ohms I don't have to consider. So this is 2 ohm, 2 ohm, 4 ohm. 1 ohm, 1 ohm, 2 ohm. So you are going to get the value of this R equivalent. This R equivalent will be equal to 4 into 2 divided by 4 plus 2. Parallel connection, 4 and 2 ka. So this is going to be equal to how much? 4, this is going to be 6. So 2, 3, 4 divided by 3. 4 divided by 3, which will be approximately equal to what? 1.3 ohms. So R net is going to be how much? R net, bacho, is going to be equal to 1.7, which is of this particular loop, plus your 1.3, that is going to be equal to 3 ohms. That is going to be the total resistance of this entire setup. By the way, what will be the current? I think it is going to be very simple right now. It will be 5 divided by 5 into 10 to the power 4 minus 4 divided by 3. If you calculate it, it comes to approximately 170 microampere. And yes, that is option B in the question. So you have understood this particular problem also. It's not very difficult. It is easy. You just need to keep your calm, be patient, and look at the problem. Yeah, it is going to be solved. All right, because sometimes the complication could be in your thought process. The diagrams might look something scary. There will be so many lines in the particular problem, and comprehending that particular question could be a difficult thing for you. But other than that, let me tell you, these questions are not very, very difficult. Okay, and you have seen that these are all previous year's questions. So if you're able to get an understanding of the previous year's question and the type that is coming, all right, you can easily master the scoring in your JEE mains, the second phase. So chalo, let's go ahead to our next question for today's session. So what do we have in the next question? Let's see something interesting. So all of you are excited, go ahead, press the like button and share it as much as possible. Okay. Now in this question, what do we have? We have got a magnetic field which is going into the plane of your screen again. I think the going into the plane of the screen is the favorite one. Okay. Most of the questions has got magnetic field into the plane. Did you observe that? Okay. By the way, let's just see this. So what is happening here? You've got a semicircular loop and it is going down. So we need to find out what will be the EMF across these two ends and which will be at a higher polarity. Okay, chalo, very nice. We look at a bigger diagram so we get a better understanding. All right, so what we have here is we'll first try to find out the EMF induced. The EMF induced will be equal to BV into L effective. This idea should be very clear. See, whatever be the shape of this particular wire, it does not matter. I just need to consider the shortest distance from the initial point to the final point. That's all matters. Now, this length is equal to what? 2 times the radius, that is the diameter. So, 2r. Clear? So, the EMF will be equal to what? BV into 2r. That's it. It is going in the downward direction, magnetic field is into the plane, and 2r is in this particular direction. So they are all mutually perpendicular to each other. Now the question is, which will be at a higher polarity, M or Q? Alright, so in order to do that, what we'll do is, we'll try to find out the force on a positive charge. So that will be Q, V cross B. Alright, so this is what we are going to have. So the force will be in this particular direction, and we'll be having Q into V cross B. Acha. Now let's say that this below direction is y-axis. Let me take it. X-axis, y-axis, and this is my z-axis. Coming out is your z-axis. So here, this is the convention that we are following for this particular question. The conventions can change from question to question. Alright, remember that. Acha. See, velocity is in which particular direction? Minus j cap cross your B vector. B vector is along minus k cap. So minus minus will become plus, and j cross k is equal to what? Plus I cap. Wow, the question is solved now. Alright, why? Because the charges will go in which direction? Towards the positive x-axis. That means this end will become positively charged, this end will become negatively charged. So you are going to have this end to be at a higher polarity. Alright, this will be at a higher potential. I hope everybody understands that. So now let's move ahead to the next question. What do we have in the next question? Let's just have a quick look. Okay, moving ahead, we have this. Wow, this is a super interesting problem. Now, what is there in this particular problem? Let me just explain this to you. Okay, we need to calculate, okay, let me keep it here. We need to calculate what? The terminal velocity of this rod in this arrangement. Now, at a side mechanics and also your EMI, I mean, your mind can go for a blast. Alright, but if I look at this question very objectively, you will see that this question can be solved in like 3 lines. Okay, in 3 lines. How exactly? 3 thoughts are very important. Let me explain to you the question. What is there saying? See, this arrangement is connected to a block of mass M, okay, and there is a pulley which is massless, and it is ideal pulley. This string out here is inextensible and it is massless, okay, so it's an ideal string, and it is connected to this rod which is going over this rail, and the magnetic field is in the upward direction. Okay, so we'll discuss everything, but right now, the first thing that comes to my mind, so let's go ahead and find out. That is the force diagram out here. Okay, so if you look at this force diagram, okay, let me just show it to you. What are the forces being involved out here? Okay, see, we'll start off with this particular force. Mg force is going to be acting in the downward direction. I think it's very clear. Okay, on the same block, if you understand, there will be tension in the string in the upward direction. See, tension here is T, tension here also it is going to be T, because all the situation is ideal. Okay, now this tension T is going to act on this rod towards the right hand side direction. But they are saying that we have to find out the terminal velocity. What is the meaning of terminal velocity? Terminal velocity means that the rod is going with a constant velocity. Acceleration is 0. If acceleration is 0, that means what? The net force acting on this rod will be equal to what? 0. And if the net force acting on this rod is equal to 0, that means if there is tension in this direction, there will be a force in the opposite direction, and this will be magnetic in nature. Alright, so this is the net force analysis of this entire situation. Alright, once we are done with this, so we will go ahead and see the next thing. What is it? In which direction will the current flow in the loop? Okay, by the way, that's not current. This is equal to current. Alright, so in which direction will the current flow in this given particular loop? See, the force on this rod should be in this direction. Now we know any current carrying, let me just take it here. Okay, any current carrying wire in a magnetic field, it experiences a force which is given by the formula F is equal to I L cross B. Clear? So this is the formula for the force which is acting on a current carrying loop. Okay, now see here, this force is in which direction? See, let me show you the convention now. The convention has changed. See, upward direction we will take it as your z-axis. This direction we will take it as my x-axis, and this direction will be my y-axis. See, simple idea. You take the fingers and curl it this way. The thumb should be actually pointing along the z-axis. So that's the reason why the y is in upper direction. Is this clear? So now you see this force will be in which direction? This direction. What is this direction? It is minus I cap. All right. L, we don't know. See, the direction of L is the same as the direction of the current. So that is what we are trying to find out. So we have this vector L. Okay. Cross. B vector is along K cap. Now, this L vector could be in two directions only. J cap or minus J cap. Simple idea, because they should be all perpendicular to each other. So it could be either J or minus J. If it is, let's say, J. J cross K is I and not minus I. So definitely this should be along minus J cap. So the current is going to flow which direction? The current is going to flow in this particular direction. I hope everybody understands this particular thought. All right, let's move ahead to the next part where we will finally see the force equation, and we'll calculate the value of the terminal velocity. Okay, so far all good. See, look at the force equation. See, try and understand the mg was acting in the downward direction and tension is in the upward direction. So I know that this entire setup is moving with a terminal velocity. So there is no acceleration. So if the acceleration is equals to 0, the net force acting on the system will be equal to 0. That means this block is also going to experience no acceleration. So I can say tension will be equal to mg. The idea is very clear. Now here there is tension T, and this will be equal to the magnetic force. Okay, that is your FB. All right. And we know this will be equal to then FB. Acha. By the way, what will be FB? FB will be equal to ILB. That will be equal to mg. All right. Now, what will be equal to I? Simple idea. What will be equal to I? Simple idea. I will be equal to the EMF generated. EMF is generated due to this rod across this ends of the rod. This is perpendicular. See, the velocity will be in this direction. The velocity will be in this particular direction. So we are taking the component, all right, of the velocity perpendicular to the rod. Okay, so here this will be nothing but BLV divided by the resistance of this entire loop. Okay, so I can write this as simply B square L square into V terminal divided by R is equal to mg, which will give me the value of my V terminal as equal to mgr divided by B square L square. All right, did everybody understand this? Yes, that is one of the options. It is option A in the choices given to me. I hope everybody understands this set of questions. That's it for today's set of questions. Now something very important that I wanted to discuss, but before that, students, if you have enjoyed this session from the very beginning itself, and if you've liked the quality of the questions that we have had for you students, you know what you have to do. Go ahead, press the like button and share it. Share it as much as possible. Okay. Chalo bacho, let's go ahead to something really interesting. Okay. Let me move ahead. So we would like to be connected with you as much as possible. Listen, try and understand that there is a Telegram app and this is the link to join a group. This group has already got 32,116 members. Okay, so let's try and understand that there are so many members. It's such a good ecosystem. Okay, and you should have an exposure to such a thing, because all the updates, all the doubts, sometimes like some students may be posting a doubt and you can get an easy access to those particular doubts. You can have your doubts and you will get to post it into the group, and there will be a solution coming from either one of these particular members. Excuse me. So I think it's a super thing. It's a super thing that you can actually have access to. So go ahead, join this particular group. All right. Acha, by the way, you have got another important thing, that is the tinyurl.com/JEE mobile. It's like a video book, and you have got all the lectures of physics, chemistry, and mathematics of 11th and 12th right here. So what you are waiting for? You have 2 months, and in this 2 months, if you want to strengthen any of the concepts, go ahead and use this particular thing. Let me tell you, students, this is all free of cost. This is all free of cost. Next thing is the Unacademy subscription. As I tell you always, it is the Netflix of education, right? See, what do you get here? Let me just count the features once. Okay. See, live classes, interact with educator. All right. See, in the YouTube, okay, we are going to be able to interact with you in a limited manner, but that is not the case when it comes to the Unacademy subscription. All right, whichever classes you are attending, you can ask as many questions as possible, interact with the educator live, and there are live polls and leaderboard. See, generally what happens in coaching, let's try and understand this. Very simple. Okay, I've been into the coaching field for the past 10 years, out of which 8 years were into offline. Right. So in this 8 years, when I would teach the students and then conduct a test by the end of the chapter, what is going to happen? I would see not say more than 40% of the class would be scoring as per my expectations. Okay. Now the reason behind that is what? See, when there are a lot of distractions in the classroom. Okay. And we are under peer pressure, which you will also agree to. Okay. So since you have got a lot of peer pressure, there are a lot of distractions, we are not able to give full focus in the class. Okay, but when you're doing the same thing at the comfort of your home, all right, and the teacher is asking you questions in between, and if the teacher finds out that that's like almost taking a mini test. Okay, the teacher finds out that there is a conceptual error in your understanding in the class itself, and there is only 20% people who has responded correctly to that particular question. Then the teacher knows that this concept has not percolated well into the students' minds. What does he do? What does he do? He repeats the concept once again. That is the benefit of your live polls and the leaderboard. You have the test series and the analysis. That is very important. And most importantly, you have got doubt clearing sessions, live doubt clearing sessions. Okay. Now, this is very, very similar to what you have in the offline, but I have seen what is the reality in the offline industry. Okay. Though they might say that there are doubt clearing sessions, but they usually do not take place very, very effectively. But here we definitely ensure that whatever doubt clearing sessions are there, okay, the teacher is right in front of you for 1.5 hours and 2 hours. You can pose as many questions as possible to the teacher, and all your doubts, they do get cleared during the session. All right, chalo students, one subscription and the access to multiple courses and all the educators, all the top educators of this country. Yeah, let's start with Namo sir. Yeah, I mean, he's such a brilliance, he's such a masterpiece. Okay, we have got DC Pandey, we have got another set of teachers out here. Okay, and we all know Jain sir, Paras sir, Samir sir. So these are all stalwarts into their fields of whatever they are teaching, and you get access to all of them. Okay, all their courses. They are not just courses which are like JEE related. They have got KVPY courses. They have got multiple other things which keeps taking place on the Plus platform. Okay, so I hope everyone's understood what is the value. Okay, now how do you go about it? The first question is, what do we have? Next is, how do you go about it? See, just go ahead, search for the Unacademy Learning app, install it right away. Okay, after you have installed it, search for the Plus part. Okay, and then once you have selected the Plus part, simple. Okay, so it's like IIT JEE, or you select NEET UG, whatever you are comfortable with or whatever your requirement is. Press on the get subscription. Once you do these 5 steps, you will be getting here to this step where you need to choose which course for 1 month, 3 months, 6 months, 12 months, 24 months as per your suitability. Okay, then the first final step comes, that is your payment. Okay, see, for here it comes to, for 12 months if you take it, it comes to 2,500 per month, and if you take it for like 24 months, it comes to 1,500. Now here I've got a good news for you. SMLIVE, it's very easy to remember, by the way. Superman Live. Okay, so that's the acronym of your SM. Okay, so going ahead, you are going to get the maximum possible discount, and this would be coming to at what, 27,000. That is so low, and for 2 years it's only 32,400. Okay, so if you do the calculation backwards, it just comes to 1350 rupees per month. It's peanuts. Let me tell you, students, it's peanuts compared to the value you are actually getting out here. You're not restricted to study from the same teacher who's teaching maybe you don't understand after a certain point of time. You're not comfortable with him, so you can keep on changing based on your comfort zone. All right, Now that's the benefit that you're going to get, and these are all coming for such a low price. By the way, you don't even need to pay all this money at one go. You can pay it in installments as well. Okay, so more of that if you're really interested in. Let's just go ahead, and you will see that after the payment link is there, there are payment options. Okay, so you can just go ahead and explore for yourself. All are this new generation kids. Okay, acha, very important things which are here. Students, if you have been listening to all of these, and if you haven't liked and shared so far, go ahead, like and share first. Then I'll tell you, go ahead and subscribe to the channel. Very important sessions are coming right now with respect to the learning and the teaching. Okay, so go ahead and subscribe to the channel. You will be well informed about whatever we are coming up with. Next thing, we are going to get the PDF notes of whatever this lecture that you have attended. Okay, so in one shot, let me tell you, okay, that besides this JEE English channel, you have got the JEE NEET, the Unacademy NEET, Unacademy JEE, and the Unacademy Foundation. So let's just go ahead, whatever you are preparing for, let's just go ahead and crack it. And finally, Superman Live, SMLIVE. Remember it and get your 10% off immediately. Thank you, students. God bless you, and see you tomorrow with your alternating current. Take care.